The final presentation for the session explores how artificial intelligence is transforming the way we connect, collect and deliver geoscience data. Presenting this work is Tasman Gillfeather-Clark, and he's the Manager of Geoscience Data Integration.
Thanks, Michelle, for the introduction. And for those of you who don't know me, I'm the Manager of the Geoscience Data Integrations branch. It's a relatively new branch to the Geological Survey, focused on AI and analytics. I want to thank CHOPS, by the way, for the topic of talking about our AI work and then immediately putting an AI discussion panel immediately after. It's very good timing. And you might note that I kind of avoid AI as a topic throughout my talk here today. We'll focus more on what I consider more important, which is the data. So if you want to do good AI, you have to have good data. And geoscience data is fragmented. And what do I mean by that? The term long tail can be used largely to describe data sets that are made up of lots of small distinct colonies of less structured, less standardized data sets. It can be described as both fragmented and heterogeneous, and in practice most geoscience data can be described this way. The problem with this is that each one of these fragmented points contributes towards a much larger narrative that characterises the geoscience of Western Australia. But if the data is incomplete, then so too is the story we're creating. If we want to complete that story, then we arrive at a very simple question. How do we convert decades of data into consistent and usable products? So when our team joined the survey a little over 12 months ago, we were tasked with creating statewide geoscience products. For teams like ours, how we answered this question is really about how we achieve that goal. Due to the scale of this challenge and the nature of cleaning large legacy datasets, we need to consider the resources we have available and align with our data quality improvements with geoscience values and priorities, all while approaching this with a focus on collaboration across stakeholders. This is a very long-winded way of saying we need to be pretty pragmatic about what we can achieve with the resources we have. So what is a pragmatic approach to data harmonisation? Well, our approach starts by taking industry data from both long-standing systems like WAMEX and WAPIMS and integrating that with newer systems being developed under the Geoscience Data Transformation Program. We integrate domain experts closely within the development process to ensure that the data output meets their standards. One of the things I'm aware of as a geodata scientist is that I'm not an expert in any given particular geoscience data set. And when you work in an organisation like the Geological Survey, chances are you have one of those experts to hand. We'd be absolute fools to try and take on the task by ourselves and implement things based on what we consider right. So integrating their expertise with the development process is really key in achieving a good usable outcome. We develop them in such a way that they're configurable. So one of the other things about experts is that no two of them agree. So you need to design software and tools that allow you to set a standard, but also allow that standard to be flexible to others who might be using your software. This results in not just a clean and harmonized data set, but a usable and reusable piece of code that we can make available. And finally, that availability is a really core component of delivering on data integration and harmonization. We put it out there on our GitHub. By distributing and promoting these tools, we hope to build a good user community, but also a contributor community. One of the things that we want to achieve is to put tools out there that will help standardize and clean the decades of industry data that really are changing for a whole bunch of reasons, both including the evolving practices of our industry, but also just variation in practice between different organisations. And then the goal long-term is to have developers in the community also contribute back to our projects. So this isn't just about GSWA owning some narrative on data quality. It's about building a community around the different data products we want to have and capturing that user feedback and integrating it with our products. It's all well and good to talk about this type of work, but delivering on it is another challenge entirely. So I'm going to talk today about our first such project that's available, which is Skippy. So for context, there's a lot of wireline petrophysical logging data submitted to the GSWA, both from the mineral sector and the petroleum sector. However, variation in the instruments, configurations, codes, and headers make using this data at a statewide scale quite challenging. Skippy emerged as a collaboration between the Geoscience Data Integrations team and Julie and Jacinta, and our domain expertise allows us to harmonise thousands of files into a consistent, reliable data set and address legacy issues spanning over 50 years of format changes, typos, and variable quality. The configurations are another important part of this, so there are lots of different processing steps required when harmonising any given geoscience data set. And whilst our expert, Julie Cass, is the designated petrophysics expert within, or wireline petrophysics expert within the Geological Survey, that doesn't necessarily mean that her opinions are the only correct set of values to use in those configuration files. One of the important things as well is that some processing steps you as a public user might not want to do. For example, we have a desurvey step, which effectively calculates the path for each step down the LAS file and calculates its XYZ coordinates. That's a really useful data output, but you might not want to do it, or you might want to implement your own version of that calculation. So just turn that step off in Skippy and it won't run, or save earlier outputs from earlier processing steps and use those instead. One of the things that I think is really important is the inputs to data projects like Skippy, and they largely come from existing data stores. So the WAPIMS team do a lot of manual data upgrading processes already from the industry data that gets submitted to us, and we're able to leverage and use those outputs in our own tool. We also receive a set of unstructured files as well, along with the reporting events, and these are the LAS files that ultimately we integrate with the databases that we have internally. Skippy ultimately takes these input LAS files and the associated supporting metadata and applies domain-specific processing and corrections, such as desurvey. And these are configurable in the event that there's a change in approach or a change in study. This is available on our GitHub today, so you can go check that out. And ultimately, this released code harmonizes the files and allows you to do lots of useful things like export it to a suitable database, as well as make it available on a usable database and make and implement your own processing steps if you wish to take it one step further by calibrating the different sensor techniques. One of the things about our data outputs is they're not static. We don't produce a single report and then never come back and revisit it. In fact, the whole goal of our products being publicly available on a forum-based platform like GitHub is that you can come to that platform and have your feedback and give us further indications on where future development might be valuable or useful. So this is just part of the evolving model of GSWA's data delivery and integration. Projects like the one I've discussed today are definitely part of the new Geoscience Data Integrations branch, but we're also helping the survey more broadly in data delivery, looking at enhancing our computational capacity by engagements with other state entities like PAWSI to enable more advanced and more powerful data processing and analysis. We're also looking at data delivery innovation by leveraging new infrastructure methods to improve accessibility, interoperability, and geoscience datasets by working closely with the GDTP. We're also exploring future projects through our development channels and public GitHub repository. So once again, you can go check that out there. You can also reach out to us via the email provided. Thank you very much.